Hello, my name is Mohammed Tawfiq and today I'll be explaining on how to add and remove nodes from a double linked list. Hello, my name is Mohammed Tawfiq and today I'll be explaining on how to add and remove nodes, how to add and remove nodes in the beginning and end of a double linked list. Let's get right into the code. The first two lines are the header files. The first header file is used in all C programs. The second header file is used because of the malloc keyword, which allocates memory of a given size to the assigned variable. Here we'll be declaring node of type struct, and with two which has two pointers, previous and next, which is used to add and remove nodes, and then data of integer data type of data type integer, and next we have a pointer of head, which is of a type structure node. We'll be having five different functions to perform different tasks. The first function, insert beginning, inserts the node in the beginning position. Insert last, inserts the node at the last of the double linked list. Delete beginning, deletes the node in the deletes the node in the beginning position of the linked list. Delete last, deletes the last node of the linked list. Displays the elements of the node in the linked list. We'll get right into the main function. The main function contains choice of data type integer, where we'll be using a while loop where choice not equal to 6. Here we have printf statements, which says to choose an option from the following. Like the options are inserted beginning, which inserts which is used to insert the node in the beginning. Insert at last, which inserts the node at the last. Delete beginning, delete last, and display the elements. These are the five options for the user to choose. We'll be asking the user to enter their choice here using the print statement, and we'll be receiving the input using the scanf statement for this choice. Let me just change this. uh, Here we'll be using the switch case for choosing the choice that the user wants. The first case is insert at beginning, second case is insert at last, third one is delete at beginning, fourth one is delete at last. Will be and the fifth one is to display the elements of the program and the default case. So if the user chooses a number which is not here, for example 6, it will go here and tell them to enter a valid choice. With this, the main function is over, and we'll be looking into the next part of the program, which is to insert a node in the beginning of the linked list. So for this we'll be using the first function, which is called void insert beginning. Void insert beginning. Here we have a pointer of type structure node item of integer data type. What this line means is that we have we have a variable called p, which has the same size of which has memory of size structure node, which is declared here. So basically what that means is p has the size of has the memory size of structure node. So when if p is equal to null, that means the linked list has too many nodes, so we cannot add more. That is what this means. It means it has been overflowed. So now we'll get into the main part of the program else. So the first part is we ask the user to enter an item value, which we receive using the scanf statement. So what head is the first position of the node, of the first node. So when head is equal to null, that means there is no other nodes in the linked list. So we'll be adding a new node in the linked list. So because of this condition, it means that the node which we will be adding will have no previous nodes, and will not have other nodes because it is the only node here. That is why point p of next is equal to null and p of previous is equal to null. We'll be assigning p of data equal to item, because we want to assign this item to data. We'll be assigning p equal to head, because it is the only node having a head. It is the first node, so it will have the same value as p. Else, okay, if there's already a number of nodes existing in the linked list, we want to add a new node in the first position of the linked list. So we'll be assigning p of data as item, same as we have done here. P of previous equal to null, because we want to add this in the first position. There should not be any other elements before that. So that is why p of previous is equal to null. P of next is equal to head, because initially the first node will have head. So because we're adding a new node, p of next will have head. That is the meaning of this line. Head of previous is equal to p, which means that the head of previous is equal to p is the current node which we are working on, and now we will change that to p, head equal to p. With this, the first node has been inserted. Now we'll be looking in how to add the node in the last position of the linked list. We'll be having two pointers, pointer p and pointer temp of struct node, item of data type integer. This is the same as we have done before, where p will have the same size as the structure node using the keyword malloc. So if p is equal to null, which means that there is no memory to be added, it will print as overflow. Else, if there is still if p is not equal to null, we'll ask the user to enter an item value using scanf statement, and we will receive the item value. So p of data equal to item. If head equal to null, which means that there is no node. The node which we will add will be the first and last node. That is the meaning of p of next equal to null and p of previous is equal to null, and head will be p. Else, which means that there are already existing nodes in the linked list. We will assign a new integer called temp, which will have the value of head, while temp of next not equal to null, which means that while this condition gets satisfied, it will keep on traversing the node until we reach the last node. So when a temp of next is equal to p, uh, I mean, if temp of next equal to p, p will equal to previous of p of previous is equal to temp, and p of next equal to null, which means that we have reached the final node which we want to add, and hence the new node is inserted. Now we'll be looking on how to Next, we'll be looking on how to delete the node at the beginning position of the linked list. We'll be declaring a pointer, a p of structure node. If head equal to null, head equal to null, which means that there is no other nodes in there is no other nodes. If head equal to null means there's nothing in the linked list, we'll print as underflow. If head of next equal to null, which means that it is the first position, uh, we'll be uh, we'll be assigning head as null, and we'll be freeing head, which removes the value of head, and hence the node will be deleted. Else, if p is equal to head, uh, if none of these conditions are true, which means there are nodes in there are already a number of nodes existing in the linked list, p will equal will assign p as head. Head will be as head of next. It will the value of head will go to the next node, and head of previous will be null. So the previous value will be null. We'll free p, and then the existing node will be deleted. To delete the node at the last, we use the delete at last function. Uh, Here we'll be declaring pointer p of type structure node, and if head equal to null, that means there's nothing in the program, so there's nothing to be deleted. We print as underflow. Else, if head of next equal to null, which means if we are already in the last if the current node, if the only node if the node is the last node, we will assign as head equal to null, and we will remove the value of head using the free function here, and the current node will be deleted. Else p we assign p as head, while p of next equal while this case is satisfied, the p will keep on traversing through various nodes until it reaches the last node, where when it does, p of previous of next will be null, which means the current the last node will be uh, the last pointer will be null, and the p will be freed, meaning that the last node will be deleted, and hence we have looked on how to add and delete the nodes. Now we'll be looking into the display function. Here we will be declaring point p, printf printing values p equal to l, while p when while as long as p not equal to as long as the p value head is not equal to null, it will print the data. With this, the addition and deletion of the given program of nodes in the linked list is completed. Now I'll be showing you the output. Here it is asking us to enter choice, so we'll be adding nodes. We'll be adding elements to the node. I want to add in the beginning, so I include one and put the value as 22. Now we have successfully added the first part. I will be adding another value at the first position again, 33. I will be adding in the last position, so I'll use 2. Now I will display the linked list here. It has been displayed here. Now I want to remove the first position, so I'll use 4. I'm sorry, I will use the 3 to remove the first element. I, the node has been deleted. Now let's look at the output. The output is 55. We have deleted two nodes, so the current output is 55. Now with this we have completed the program. Thank you.